Imagine yourself as a kid, walking through the busy streets of London, towering buildings, flashing ads, hurried footsteps, car horns, and the overwhelming city buzz. For many kids, this is their reality. How can we create places where they can play, learn, and grow in this concrete jungle? Research shows an increase of 25% in school absences last year, and with 42% of kids living in poverty. London has the highest concentration of children aged 0 to 15 in the UK, but the population in inner London is significantly lower. High living costs and limited space push families to more affordable, spacious areas in outer London. Thus, this project designs integrated urban spaces where children can explore, learn and grow on equal footing with adults. We gathered different datasets related to children in London and mapped them out. The datasets included the number of children that go to school, child obesity, fast food outlet counts, and transport accessibility. We analysed the interrelations among 18 distinct datasets as shown below. We found out that obesity percentage and transport accessibility are positively correlated to other datasets. We used principal component analysis, PCA, to explore key factors affecting children's development and education. PCA revealed Brent as a prime location due to its balanced representation of influential themes. By combining PCA and K-means clustering, we identified patterns that highlighted Brent's challenges, including low school attendance and high negative influences. This informed our decision to focus on Brent, using detailed network, location, and demographic analyses to narrow down the ideal intervention site. We used Pix2Pix and generative adversarial networks, GANs, to turn complex datasets into visual maps. By training the model on London data, excluding Brent, we visualized Brent's unique challenges. We combined 6 dataset stacks, each linked to key factors in child development, to pinpoint high-priority areas. This approach helped us narrow down potential sites by focusing on the top 10% of data points and school catchment areas. We calculated the shortest angular paths to assess urban connectivity, where the green tones on our map show highly connected spaces. Using integration and angular segment analysis, we initially shortlisted 4 sites, each with 2 or more schools and high integration. Based on a couple of requirements and criteria curated by us, we focused on sites 1 and 2, ultimately combining them to select the most suitable location for our project. ISAVIST analysis shows high visibility and connectivity along highways and railways, with clear sightlines between the 5 schools. We ran an agent simulation to model children's movements, observing 80 kids navigating for 10 minutes with a direction change parameter to mimic their curiosity. We'll preserve strong visibility in our design to enhance holistic development for children. We analyzed the point of attractiveness and pedestrian use at different time intervals using GPS points. These analyses helped us with K-means analysis, as we used GPS points, step depth, integration, and the eFood Desert Index to guide our pathway design to ensure strong connectivity and accessibility among the 5 schools. The master plan starts off with the K-means points. The points were filtered down by analyzing their proximity towards the schools. Integration values of the site, underlaid in red, were to give a sense of the interconnectivity of the site within the context of the other data. A proximity analysis was run on a second, more refined cluster of points from the K-means analysis. Our design tackles essential gaps like creativity, emotional, financial, and social skills with 8 interventions, addressing 5 potential inhibitors to development. Using Forest School principles, we emphasize nature-based, hands-on learning for holistic growth. We created design iterations using an evolutionary algorithm that used the 2 design elements of solids and voids as the base form. The iterations were fed 3 fitness parameters which were essential to creating spaces suitable for our design interventions, and they are max volume of void, minimum volume of solids, and max area of solids. Our site plan starts off with our designed path in white within the context of the surrounding Brent area and the schools highlighted in grey. The site is segmented into 2 pathways, the main pathway and secondary pathway. The interventions and educational spaces become suited to specific age groups in chronological order as one walks through the site. For each one of our interventions, we paired them and placed them in the most suitable age group in terms of significance to their development at their age. The reading space intervention serves as an active book swap space where children can share and discuss books in a positive, open-spaced environment. The farming tunnel intervention serves as a living laboratory for environmental education, offering opportunities to learn about sustainability, conservation, and food sourcing that are often overlooked in traditional school curricula. A market space led by children offers a unique educational environment that promotes autonomy, independent decision-making, and entrepreneurial thinking. The playground serves as a bustling social arena, encouraging children to navigate social relationships. The forms of our playground elements were influenced by popular kids' toys that were LiDAR scanned to extract a point cloud scan. The playground encourages them to think outside the box, climb, jump, run, and problem solve, transforming traditional learning into exhilarating adventures that fuel their innovative spirit. The color analysis of child-loved animated cartoons allowed us to extract colors correlated to core values crucial to a child's development. The design concept of the emotional interactive tower stems from isovist analysis. A series of steps were taken to achieve a highly visible and high surface area structure. An emotional interactive tower uses color to revolutionize children's understanding of emotions by immersing them in a vivid world where colors become the language of core values and feelings crucial to a child's positive development. The pathways are brimming with nature trails and community gathering spaces, enhancing the educational aspect of the site, providing opportunities for exploration and social learning. Raised viewing platforms throughout the site, such as this one in the tropical garden, allow the children to gaze towards the entire site from an elevated position, empowering them. Exposure to an abundance of natural elements such as water streams and vegetation foster shared engagement between children and are linked to increased academic performance and attention.